Hey guys, in this lesson we would understand the applications of vertex form of quadratic relations with the help of a word problem. The question that we are given is, at a firework display, a firework is launched from a height of 2 meters above the ground and reaches a maximum height of 40 meters at a horizontal distance of 10 meters. We have to determine the equation to model the flight path of the firework. Because we have to write down the equation, always remember whenever the question or any word problem that talks about a maxima or a minima, then the equation can be best written in vertex form. So from here we know that this is going to be a vertex form of equation because the question talks about a maximum value, and here we have a maximum values of maximum height. So after we know this is vertex form of equation, we would write down the general vertex equation, that is y equal to a x minus h whole square plus k. Now since we know whenever we have to write down an equation, we need to fill in the values of a, h and k. H and k are going to be the vertex and a is something that we have to find out from the graph. So let's turn this word problem into a graph. Now whenever we have to make a graph, we always have an x-axis and we have a y-axis. In this particular problem, the two variables that the problem talks about is height and distance. Height is definitely vertical height and distance is horizontal distance, and that is mentioned here. So the x-axis is going to be representing our distance and y-axis is going to be representing our height. Therefore, on the x-axis, we write down the variable as lowercase d that represents distance, and y-axis is variable uppercase h that represents the height. So in this general equation, y variable can be replaced with height. We would use uppercase h here so as to avoid any confusion between this uppercase and lowercase h. And in place of x-axis or x value, we would be using lowercase d. Now coming back to the question, they say firework is launched from a height of 2 meters. Because its launching height is 2 meters, that means 2 meters is the height when distance is 0. So launching height is always the initial height. And initial height means the height when the other variable that is the x value variable is 0, and that we would mark here somewhere. Another information we are given is this firework reaches a maximum height of 40 meters. So this firework reaches a maximum height of 40 meters at a horizontal distance. The x value that is going to be at 40 meters is 10 meters. Because we are given the horizontal distance to be 10 meters at height 40 meters. Now we know this is the vertex of the parabola, and vertex is represented with lowercase hk. So h is 10, k is 40. That's what we would be using in the equation. H is 10, k is 40. A is something that we are solving for because a is something that we cannot read from the graph. And in order to solve for a, we have to sub in for uppercase h and lowercase d, that is the height and the distance, or y and the x value. So on the graph, we would look for another point that is given to us, and the other point that's given to us is this 0, 2. 0 represents the lowercase d value or the distance value, and 2 represents the height. So we would sub in the distance as 0 and height as 2, and we would solve the equation. 0 minus 10 is negative 10 squared, that is 100, times a is 100a, plus 40 equal to 2. When we move this on the other side, it gives us negative 38 equal to 100a. So a is equal to negative 38 divided by 100, that is negative 0.38. And the final equation that we would get is height equal to negative 0.38 d minus 10 whole square plus 40. So this is the a value, this is the h value, this is the k value, and y and x are going to remain as variables. The next part of the question says that the firework continues to travel an additional 1 meter horizontally after it reaches its maximum height before it explodes. What is the height when it explodes? So second part wants us to find the height, that is uppercase h, when it explodes. Now we are working on two variables in this particular question, that is height and distance. So if the question wants us to find out height, the question has to give us distance such that we can use the equation that we have obtained in part A, in which we can substitute the distance as we already have A, H, and K as values in the equation. And once we have D also substituted in there, we would be only left with the height to solve in this particular equation. Now for distance, they have given us this information, and the information says that the firework continues to travel an additional 1 meter horizontally after it reaches its maximum height. That means when this firework keeps traveling for the next 1 meter distance, and then next 1 meter distance means 11 meters on the x-axis, they say when it travels 1 meter horizontally after it reaches its maximum height, so that's why we are moving from the maximum height point 1 meter towards right, the firework explodes. So this is where the firework is going to explode, and the distance it explodes at is 11 meters. The question wants us to find the height when it explodes. So we are looking for the height when the firework explodes. Now if we try to locate height on the graph, we would not be able to find out the exact value of height. We know it is going to be less than 40, but we don't know what is the exact value. That's why we would use the distance 11 meters in the given equation that we have obtained in part A, and that's this equation. So when we sub in D as 11, we would be able to solve for height. Therefore, we substitute D as 11 in here. All other values are already there. 11 minus 10 is 1, square is 1, times negative 0.38. When we put this all in the calculator, we get 39.62 meters. So that is the height that we obtain when the firework explodes. Next part of the question says at what other horizontal distance is the firework at the same height as in part B. Now part B gives us the height at which this firework explodes to be 39.62 meters, and this is at a distance of 11 meters. They want us to find out what is the other horizontal distance that has the same height as 39.62. What is the reason they want us the other horizontal distance is that we know parabolas are always symmetrical graphs. So if when x is 10, y is 40, we have a vertex. So this is our vertex 10, 40. All the points around this vertex, both on the left and the right side, is always going to be symmetrical. So if this value, height, is 39.62, so will be this value for height. So on the right side, if this occurs at 11 meters, on the left side, it will occur at 9 meters. Because of the graph being symmetrical, these heights are always equidistant from the vertex. So the same height, 39.62, would occur at distance 9 meters. So when they ask us what is the other horizontal distance with the same height as in part B, the answer is going to be 9 meters. And this is how we do word problems. When it comes to vertex form, the best way is to always turn the word problem into the form of a graph so that we can use the graph to turn it into an equation. In case equation is given to us, then we just have to read the values given in the equation to answer the questions.